known value, and score. Okay. Oh, argument must be passed with the out. Okay. Out, known value. Great. Let's see if that runs. Okay, yep, not all. Okay. First of all, cannot convert from int r int c to int r direction d. Where is that happening? Right, not all code and not all codes pass return a value. Return null. That should fix that. Okay, argument 1 cannot convert from int rc. I really, really wish there was a way to get more effective line numbers here, because that's the one thing is these things tell me where things are, but not very well. 6838. Actually, is that like in my settings somewhere? Customize notebook. Wait, hang on. Did I just see that there? Outline. Toggle notebook line numbers. Oh, hallelujah. Okay. Int current value equals best value seen of. Right, P is a position, so that isn't going to help me there. Right, was why we were doing this thing. Run this. Great. Now, having done that, we want to best path cells. We'll add a new code block here, and we'll just go ahead and set this thing up again here. Best path cells of that. All right. Run all. Okay, and so here we go. And yep, that gives us a bunch of cells, each of which is initialized with the worst best value we ever saw for it. Yep. Oh, but actually, hang on. That doesn't tell me it's on the path. Because, yeah, it might be the worst. It might be the best. Okay, I think I might still need directionality data. Okay. Let's see. So we compute the best path. And okay. Actually, let me just see here. What I'm just going to do here, I am going to take this best path. So I'm going to actually. All right. We're going to copy the cell. And now I'm going to paste this cell here. This is the real version. Okay, and we will go ahead and collapse that one there. Okay, so what I want to try here is, because I don't want to throw that away because I think I might still need some of it, but all right. So we had compute best path. What if we run it again, but this time it already knows a whole bunch of stuff? So int, and this one then needs to be needs to give me a list of coordinates. Okay. So now we need to and actually, yeah, the priority queue does not need to exist outside of this thing. Oh. Or maybe it does? No, we can, yeah. Yeah. Okay, recompute. We'll also clear best value seen just to avoid having any weirdness. Okay, great. So there's that. So now best path seen does that. But here we again need our positions to evaluate here. We'll do that. All right. Now we can't return current value. So here we are. So now what we want to do is, right, we dequeue a position. The current value of that position is best value seen. And what we want to do is we want to see, best value seen will contain every position at this point. So we'll come back to this. This is the base case. This will not happen. So if the best value seen for that other position is, I think, less than or equal, no, is I guess, yeah, equals the current value plus the cost, then that means we want to be reevaluating this position to enqueue, and we're going to need to add this to the result data set. So list coord result equals a new list. All right. Result.add. And it's going to be result.add p. And then we'll enqueue that other position to look at there. Right, p dot position, or p, I guess. And actually, this shouldn't be a list. This should be a hash set. Because that way, if something gets put in it twice, whatever. Okay, so there we go. And then we evaluate that. And now, just whatever, when we get to the end of this here, we say return result, whatever's there. Okay. And if we're start, we're going to say result dot add p and break. And now what we just want to do here is return recompute best path. Run all. Cannot implicit, into system generic list, right. Run all. Empty. Okay. Not quite what I was hoping for, but you know. Let's take a quick look at what happens here. All right. Run all. Run all. So that never even happens. From positions P. So we don't even end up there. Okay. So something's going wrong here. recompute best path. There must be some other bit of setup I need to be doing here. So we do compute best path. Oh, right. We have to do this in queuing, don't we, here? Yeah. There we are. Lots of stuff on path. Lots of spew. There is a timer on this, so hopefully we will not implode, but we may make ourselves sad, but we'll let this thing. Yeah, the problem is printing is expensive. So the fact that we had so much of it from an attempt to debug. Okay, did we reach an end? We reached an end. And then there's a list of 82 plus 20, so 102? That's concerning. Part of it. So we are looking at example what? Partial data once. We're looking at the first example. Okay. Okay, so thing one, we're going to remove these print statements. Thing two, we're going to rerun. Good, it runs very quickly now. And thing three, we're going to visualize this. So void visualize map cells. All right. And what we're just going to do here is it's going to be char two-dimensional map and IEnumerable coord cells. All right. For int r equals 0, r less than map dot length r plus plus. For int c equals 0, c less than map dot length c plus plus. All right. Or sorry, not map dot length, map sub r dot length. Okay. If cells dot contains r comma c, row dot append and o. Else row dot append map at rc. And string result, okay. Now we just end up saying result dot add row dot toString. And then actually we don't even need that. We just need to say print row. Okay, let's see how this works. If we say then var cells equals that, and then we say Visualize map cells, map cells. Run that, run that. Okay. Yeah, that's a problem. That found basically. Oh, right. That doesn't find. That finds if this place is. Yeah. Yeah, that's the problem. That finds if basically this place is reachable without going someplace you really shouldn't go. Okay. Right. So we evaluate backwards through a lot of stuff, but if we don't get there from the start, hmm. Okay. So as we walk that path right, we look at those paths, that's the. Oh, right, because we'll find each of those eventually. Um okay, so we've got these positions right. We have right because we can't know any of these things until we know if we're on a best path. So the fact that we did this non-recursively is gonna bite us. Okay. So right. What we need to do is we kind of need to work back and confirm whether the path we are on gets us where we need to be. So, all right. The priority queue method isn't going to help us here. What I want to do is I want to say, to recompute best path, really we're going to recursively compute the best path, or recursively we want to answer the question of is this on the best path? Which means, right, are we on the best path to here? Um, I'm trying to think about how I want to approach this. Because if we're on a best path, then that means we've got what's the word I'm looking for? What does it mean that if we're on a best path? I mean, if we kind of take this thing, this score is going to be 0, but then yeah, these both have the same score. The problem is that this one eventually reaches a spot where it's no good. And like at this point, when this can't get back onto here, this needs to invalidate everything that depends on it for its best pathness. I mean, I see a solution. It's kind of weird, but okay. Let me kind of run this. So actually what I want to do here is I want to say, right, if so for each of these, if I look at my output there, like, that did happen. So, okay. As this thing's going on here, right, we have our positions. If the best value seen is there, like, I want to know what happened at this cell here, because that's like, that should not have linked to there. So that should have been like a gap. Even if it came down, as it came down from here, it should have been like, wait a minute, I am not part of the best path to this point. Although I guess it looks at, no, yeah, at all the from positions. So, okay. Because, yeah, the best value seen for that position. Mm. Yeah, we could go in different directions through some place, but okay. All right, the best value for a position is the current value plus the cost. Then it's the question of, are we on the path? No, right. That's not how we. Oh, I guess there's always a best value seen from that position, right? If that cell, that's part of the problem. Is that, yeah, any of these, like, because of the way orientation is pulled into this. Um, hmm. I mean, okay. The the fact that positions to evaluate is a priority queue means I should really be. I guess I really should. Well, I guess I'll be looking. No, I guess it is kind of depth first there, or breadth first, and I kind of. No, I kind of need it to be breadth first. But then I needed to invalidate things that aren't good enough. Okay. The adding of directionality to the maze is actually very interesting for what it does for kind of this tracking. Um, I mean, actually, wait. Okay. Hang on. If we compute the, let's go back to how we compute the best path here. We do all this. We have our positions to evaluate, and if every position has, like, we get that position, it has a cost. So, okay. I'm kind of thinking about, can I be storing these chains as we go? So, right, each one of these things It's like if the best value that we've gotten for something is, all right, it's a number. What if we change that? What if that is, right, that is dictionary position to um, okay, let's try something here. Using list of position path, or using path as list of position, route, and int cost. List cannot be found. There we are. Oh, systems.collections.generic. Okay. So that's a path. So now we want a dictionary from position to path, best path seen. Okay. So now we still do this, but right, we get the from position. So now start out. We clear the best path seen. And now we're going to add to the best path seen end p comma 0. And the positions to evaluate, we enqueue end p 0. Okay. So now int current value was best value seen, but best value seen isn't real anymore. So what we need to say instead here is it's going to be int, actually, it's not quite that easy because it's not just best path seen, it's best paths seen. We have that list there, which is a route. You're so close. Okay. So I need to store possibly multiple paths alongside each other, but they'll always have the same cost. Which means actually, yeah, it's just going to be a list of paths. Best paths seen. All right. Okay. And then we enqueue that position. So now var current paths is best paths seen of p. All right.